These are just from WebAssign. I just took them off WebAssign. I just kind of made it look a little different. But you're going to have to graph and then eliminate the parameter. So when you graph, you're just going to be plugging in values for t. I'm going to tell you what values to plug in, so it's nice and easy for you, tailor-made. You can also use a scientific calculator. No graphing, but you're welcome to use a scientific calculator. So you make decimal equivalents, whatever you need to do to graph. So remember, with graphing, what is important about the graph? Once you plot the points, you connect the dots. What's really important to put on the graph? The little arrows. You got to show the orientation. When it says show the orientation of the curve, that means, hey, put the little arrows to tell me what direction it's going. When it says to eliminate the parameter, what does that mean? Get rid of t. Good. Eliminate the parameter means get rid of t. You're going to take one equation, set it equal to x or y. I'm sorry, you're going to take one equation and get t by itself. Doesn't matter which one you do. It doesn't matter if you have x equals or y equals. It does not matter. And you're going to use substitution. And then your rectangular equation is what you're looking for. It just has x's and y's. When it says eliminate the parameter, it means get rid of the t. So in a case like this, where it says to graph, show the orientation of the curve, I'm going to tell you guys what to use for your t values. Right here, I'm going to say from -2 to +2. So what we do is we set up our chart, right? We're going to use our t values. This is our time. So -2, -1, 0, 1, and 2. And what we're doing is finding at the exact specific point in time what your xy coordinate is. So you take 2 and you plug it into each equation. You take 1, you plug it into each equation. You take -2, whatever the number is, you plug it in. So I'm going to take -2 and plug it into the x equation for t. So 2 minus 3 times -2. What's 2 minus 3 times -2? Thank you. -3 to right. This becomes 2 plus 6, which is 8. So your x value here is 8. Now I'm going to plug in -2 and put it into the y equation. So 3 plus 2 times -2. What's -2 and +2? This is going to be 3 minus 4, correct? So I get -1. You guys agree? Everybody with me? Okay, so same thing. Now I'm going to take the -1 and I'm going to plug it into the x equation. So 2 minus 3 times -1. What does that equal? What's 2 plus 3? 5, okay. And now I'm going to take -1 and plug it into the y. So 3 plus 2 times -1. Well, what's 3 minus 2? +1, okay. Now I plug in 0. So for x equation, I have 2 minus 3 times 0, which is what? My x value is 2, good. Then into the y, I have 3 plus 2 times 0, which is 3, good. Then I take the 1, so I have 2 minus 3 times 1, which is -1. Then I have 3 plus 2 times 1, which is 5. And then I plug in the 2, so 2 minus 3 times 2, which is -4. And then I have 3 plus 2 times 2, right? Which is 7. All right. Now, you can use a calculator for all those things. Anybody have any questions about where I got those points? Now, what do? We graph these points. If you want to remind yourself, this is where you're going to start when you connect your dots. This is where you're going to end. That might help you with your direction. You always start with the smallest t value. So I'm going to just a basic graph, right? So 1, 2, 3, 4, 5, 6, 7, 8. All right, you guys are going to make your own. So 8, -1. So 8, -1 over here somewhere. And then 5, +1. 1, 2, 3, 4, 5, +1. And then 2, 3. So 2, 1, 2, 3. And then -1, 5. So -1, 1, 2, 3, 4, 5. And then what? -4, 7. 1, 2, 3, 4. And then up here to 7-ish. Where do I start drawing my line? Or curve, not necessarily a line all the time. It could be any shape, but where do I start? Which point? The 8, -1, right? So I'm going to connect. I'm going to go like this. And then what is important to have on that graph that I just drew? The arrows. Which direction does it go? Like this. How do you know which direction it goes? Well, tell yourself where you start and where you finish. Write down your starting point and your ending point. How many arrows do you have to have? I don't know, 3 or more. Just something that shows the direction. Does anybody have any questions about that? All right, so then the second part of the question is to eliminate the parameter, which means to do what again? Get rid of t. So x equals 2 minus 3t. And y equals 3 plus 2t. Now, there are 2 different answers you could have here. Your rectangular equation, which is what we're looking for, I'm going to put in this box, could be x equals or could be y equals. It doesn't matter because they both are the same thing. Algebraically, guys, if you do this correctly, you could have 2 different answers. I'll show you both of them. Which equation would you like to solve for t? God bless. It does not matter which one you want to solve for t. X or the y equation? The y? Okay, so we're solving for t. I'm trying to get t by itself. So what would you do? How would I get t all by itself? I'm going to subtract 3 from both sides. Good. So you have y minus 3 equals 2t. And then what? I'm going to divide both sides by 2. So you have t equals y minus 3 over 2. Does everybody understand that? So you solve one equation to get it to say t equals. And then what do you do with that? You plug it in to the other one. So I'm going to take this value, and where I see a t, I'm going to plug it in. So if I'm going to solve this, I have x equals 2 minus 3, and then I put in y minus 3 over 2, correct? Now, algebraically, guys, we think algebraically, we're going to simplify this. X equals, that 2 is hanging out here. What do I do with that 3? I'm going to distribute it. So negative 3 times y is minus 3y. Negative 3 and negative 3 is plus 9. Everybody agree? And then over 2. Everybody with me? All right. Do you agree that these are 2 fractions? You're subtracting fractions? How do you subtract fractions? You get a what? A common denominator. What's the common denominator between 2 and 1? 2. So if I make this a 2 on the bottom here, what do I have to multiply the top by? 2. So this becomes what? 4. Now do they have the same denominator? Yes? So can I combine like terms? The 4 and the 9? You guys agree? So this is the same thing as negative 3y plus 13 over 2. Now you can write that a variety of ways. You could write it negative 3y over 2 plus 13 over 2. You could say 13 minus 3y over 2. But this is your rectangular equation. So there's 2 parts to these questions. You're first going to graph. Make sure you substitute in whatever values I tell you for t. And then make sure you show the orientation, the arrows. And then where it says to eliminate the parameter, this is what you're looking to do. Now, some of you might look at this and say, okay, here's my 2 equations. Are they going to be super duper straightforward and super easy every time? No, there might be one that is a little more difficult, algebraically challenging, but nothing pre-calc that you guys can't handle. It's all algebra based. If I look at this and I say, well, I personally would have eliminated or solved for t on this side and then substituted the other way. That's fine. What would I have done here? Subtract the 2. So I have x minus 2 equals negative 3t, and then what? Divide by negative 3. Okay, so that means I would take this value and plug it into the other equation. I'd put it here. So y equals 3 plus 2 times, and then I would plug in x minus 2 over negative 3. Everybody with me? I switched it. I did the other one just because maybe that's how your brain saw it. And that's fine. We're going to still algebraically do the exact same thing. I have y equals 3 plus, what do I do with that 2? I distribute it, so I have 2x minus 4 over negative 3. Now, if I'm going to add these together, algebraically, what do I need? A common denominator. What's a common denominator between negative 3 and 1? Okay, so multiply this by, and then this. So this becomes negative 9. Agreed? Okay, so I have y equals, can I combine like terms? So I have 2x minus 13 over negative 3. Could I write it 2x over negative 3 plus 13 over 3? Yes. Could I write negative 13 plus 2x over negative 3? Yes. But this is your rectangular equation. Both of these are fine. As long as algebraically you do the problem right, it does not matter if you solve and it says x equals or if you solve and it says y equals. It does not matter, whichever you guys are more comfortable with. Questions? We okay? All right, look at the next one. Let's just say we go, let's go negative 2 to 2 again. All right, is this a little easier? Yeah, there's not as much math involved here. I'm going to just plug in negative 2, negative 1, 0, 1, and 2. So now I look and I say, okay, well, every time I plug in to my x equation, what am I going to come out with? The number I plug in, right? If I have x equals t. So I could just go ahead here and say, okay, this is negative 2, negative 1, 0, 1, and 2. I already know what the x values are for all of my ordered pairs. Do you have to make this chart so I see it tomorrow? No. I do need to see what your ordered pairs are. Like you can't just put random dots and stuff like that. I need to actually see the ordered pairs. Like I need to know what your x, y values are. But if you don't organize it exactly like this, that's fine. I don't think it's a good idea for you not to, but you know, to each their own. So what do I do here when I plug in? I'm going to plug in for my t value and y. So when I plug in negative 2, what does this value become? Negative 2 over 3, right? Then I have negative 1 over 3. Then I have 0. Then I have 1 over 3. And then I have 2 over 3, correct? You guys with me? Okay, so where do I start? At this point here. Where do I end? At this point here. That might be helpful for you so you understand the directions that your arrows should go. So again, you guys are going to make your own graph. So make this a little wider since our numbers are kind of small. So negative 2, negative 2/3. So negative 2, negative 2/3-ish. Negative 1, negative 1/3-ish. 0, 0. 1 and 1/3. And then 2 and 2/3. So I'm going to start at this point here and go here. And then what do I need to have on here to show the proper graph? I need my arrows to show my orientation. Now, somebody asked me last period, can't you tell what the shape of your graph is going to be by your equations? Absolutely. If something is to the first power, what shape is it going to make? A line. If it's to the second power, then it's going to make a what? A parabola-ish looking thing of some point. If it's to the third power, it's going to make a cubic looking thing. So you should have some sort of pattern to your dots. It should not be random where it looks like my daughter did her own connect the dots, right? You should have some sort of shape. Let's look at the... Yes, ma'am.
1, 0, 1.
Yeah. Yeah. Like here, are these both, are the, when I graph this, is this going to make a straight line? Yes or no? How do you know? Because one of them is squared, right? So look, exponents make a difference. They make a difference in your numbers. They make a difference in your math. They make a difference in your graph. So just pay attention. Again, what am I telling you to use here? Negative 2 to what? 2. It's going to tell you to graph the curve and show the orientation. That means plug in all the t values to the x and to the y, find the ordered pair, plot the points, draw your arrows. Then it's going to say eliminate the parameter, which means get rid of t. And write your equation as a rectangular equation. That just means got to have an x and a y. So I'm going to go down the list here. I have -2, -1, 0, 1, and 2. I think it's a really good idea to show me what you guys are putting in your calculator, just in case you make a little mistake. So in the x equation, when I plug in -2 squared, what do I get out? 4. And then in the y, if I have -2 minus 2, what do I get out? -4. Remember, when you put negative numbers in your calculator to square, they become what? Positive. If you put this in your calculator like this and hit enter, your calculator will tell you it's -4. Is that true? Is -2 squared -4? No. But the way that it's written, just like that, that is a true statement because your calculator will square the 2, then add the negative in front of it. You need to tell the calculator, hey, take the number -2 and square it, then it will come out to be +4. All right, so -1. I'm plugging -1 here. -1 squared is 1. Then I plug in -1 minus 2 gives me -3. Plug in 0. 0 squared gives you 0. 0 minus 2 gives you -2. Plug in 1. 1 squared gives you 1. 1 minus 2 gives you -1. Plug in 2. 2 squared gives you 4. And then 2 minus 2 gives you what? 0, right? So this is where I'm going to start. And this is where I'm going to end. So over here, your biggest value is 4. Just make sure your graph fits. You're going to write your own tick marks. So 4, -4. 1, 2, 3, 4. Down. 1, 2, 3. Somewhere around there. 1, -3. 0, -2. 1, -1. And then 4, 0. 1, 2, 3, 4. So again, this might be helpful for you to see, okay, I'm starting my connecting here, and I'm going to end it here. So my arrows should be going in this direction. Everybody with me? This is what I need to see tomorrow when you guys are graphing. And then to eliminate the parameter, remember, just think algebraically. Look at the example I did on the video where you had fractions and you had t's you had to get rid of. You have to be able to think algebraically, guys. It's like algebra 2. Once you figure out what eliminate the parameter means, that's the pre-calc part, understanding that means, ooh, get rid of what? Get rid of what? T. Right? In this case, guys, eliminate the parameter, get rid of t. Does it matter which way you go? Absolutely not. We'll do it both ways. I'm going to take my y equation, and I'm going to eliminate, I want to get t all by itself so I can eliminate it. So I'm going to do what to both sides? Add 2, right? So I have t equals y plus 2. So what that means is I take this value and I substitute it into the other equation. So I have x equals, instead of t, I have the quantity y plus 2 squared. What does y plus 2 squared mean? Y plus 2 times y plus 2, okay? So when we FOIL this out, y times y is y squared. Y times 2 is 2y, plus 2 times y gives me 4y, correct? Plus 4. There is my rectangular equation. When you eliminate the parameter, you get rid of the t. You solve one equation, so it says t equals, then you plug that into the other one, and then you're going to end up with an x and a y in your equation. Now, if I went the other way, could I absolutely do that? Of course. If I started out here at x equals t squared and y equals t minus 2. If I'm going to solve for t here, what would I do to both sides? Take the square root, okay? So you have t equals the square root of x. Am I missing anything? Very good. What should go in front? What should go in front? Plus or minus, right? Good, very good. So what we're going to do here is take this and plug it in where? Right there. So this becomes y equals, instead of t, I have plus minus the square root of x minus 2. And there's your rectangular equation. Those two things are not, these aren't the same because you solve for different variables, but you're solving in the same way. I'm not saying that your equation, if you solve for x versus you solve for y, should not look identical. So you can't check yourself at, why aren't they the same? It doesn't work that way. But if you solved, they'd be fine. Questions? All right, rewatch the video. Rewatch 9.4 notes for a refresher. Remember, I also put up that video in modules, the Khan Academy video that was just kind of an intro to parametric. We do not go as in-depth as the other pre-calc class. It's just not in our curriculum. But you guys do need to see it, but we're not going to go as in-depth.